Okay, so today we're going to be talking about scatter plots and association. This is going to be the first lesson in Unit 5. And up here at the top, you can see that we have our unit, which is scatter plots and data analysis. This is going to be our first handout for the unit. And it's going to be really good. So this is the first video in the series of lessons for the unit. Please make sure that you write your name at the top of the page where it says to write your name. You should have already had a packet given to you in class. If not, make sure you come see me. Or you could open up your OneNote and you could kind of follow along, but it's going to be hard for you to watch the video and use your OneNote at the same time. Maybe if you're watching the video on your phone or using a computer or something like that, it would just depend. But I would recommend having good old pencil and paper while you're watching the video and filling out the notes. So we're going to be talking about scatter plots and association. Something that you're really going to want to make sure that you think back to is that last unit, Unit 3 and Unit 4. We kind of combined those together, but we were talking about slope, we were talking about y-intercept, and we were using formulas and equations to solve all of those things. You should remember that a positive slope is increasing from left to right and a negative slope is decreasing from left to right. And that was whenever we had really good, solid linear equations. They created a line when we graphed them, but here we're going to be talking about scatter plots. And if you think about scattering things like scattering seeds or scattering leaves, they kind of all fall out and it almost looks random. But what we're going to be doing is we're going to be looking at graphs that have points kind of scattered across them, and we're going to see if we can find some positive trends, if we can find some slopes by looking at those scatter plots. So here we're going to fill out some notes for scatter plots, and it says, scatter plots are graphs that use points to display numerical data. And numerical is just a fancy word for numbers. Okay, so we're going to put numerical in U-M-E-R-I-C-A-L. Very good. With two variables or bivariate. B-I-V-A-R-I-A-T-E. Okay, and I'm trying to make sure that I go ahead and spell out the words as I'm writing them, because y'all all know that my handwriting is not that great. When we're talking about bivariate data, kind of think about a bicycle, okay? It's bi, which means two, or two wheels on a bicycle. So we're going to have bi meaning two, and variate, the root word here is to vary, and it's talking about variables. Okay, so it's going to have two variables. And if you think back to those linear equations when we were solving for slope and things like that, we've been working with bivariate data for a while because we've always had two variables. We've had an x and a y, so we're really not changing anything there. We're just kind of giving it a good mathematical name. And then it says scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations between the variables. So here in this blank, we're going to write associations. Between the variables. Okay, so we're going to kind of look at this example of Susie over here so that we can dig a little deeper into what it means to be looking at scatter plots. It says Susie went to the mall and surveyed shoppers to see how many items they'd purchased and the total amount of money they'd spent at the mall. She created the scatter plot below. And A says, how many shoppers did Susie survey? Okay, so we're looking at A. How many shoppers did she survey? Well, we can look to see how many shoppers she surveyed by counting the number of dots on the graph, right? Because each dot represents a number of items that the person bought and then the total amount of money that the person spent. So each of these dots is going to represent the person. So we're going to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So Susie surveyed 16 shoppers. Okay. B, does the number of items purchased seem to have an effect on the amount of money a shopper spent? Okay, so if we're looking, they buy one item, maybe $40, another item that was more expensive, it looks like it's going to cost about $90. And if you look, the more items that these shoppers are buying, the price is going up. right? The amount that they're spending at the register is going up, and that makes sense, right? If you go into Walmart and you're just going to buy a pack of M&Ms, you're not going to spend that much money. But if you walked around with your parents and y'all just filled up that buggy because y'all are buying groceries for the month or a couple of weeks, you're going to spend a lot of money because you bought more items, and that makes a lot more sense. So we're going to say over here where it says explain, we'll say yes, because the more items they bought, the more money spent. Right? That makes sense. The more items they bought, the more money they spent. So we're going to talk about positive associations, negative associations, and no associations. Okay, and that's going to look very similar to when we were talking about slope. Okay, so when we're talking about positive associations, it says two variables have positive association when the variables move together. Okay, so here in this blank, we're going to write together. For example, as one variable increases, the other variable also increases. And that's kind of like what Susie was looking at with the shoppers up there, because as the number of items increased, the amount of money also increased. So they were moving together like at the same pace. So they have a positive association. And if you look at this graph over here, the numbers are slowly going up, right? And that looks like a positive slope. And so it's going to be a positive association. When we're talking about a negative association, it says two variables have negative association when the variables move in opposite directions. So we're going to write opposite. For example, as one variable increases, the other variable decreases. Okay, and that could be used like if we were plotting data about the amount of hours you exercise versus the amount that you weigh, right? Because the more that you work out, that's going to go up. Say you work out 1 hour a week, 2 hours a week, 3 hours a week. As that number grows or increases, your weight would decrease, right? I guess unless you're a bodybuilder and you're putting on muscle and things like that, I guess it might increase. But we're just going to say that it would decrease if you were trying to work on losing weight or something like that. Okay, so that would be a negative association. And negative doesn't necessarily mean a bad thing. It just means that they move in opposite directions, or one is going up while the other is going down. Okay? In no association, two variables have no association when the change in one variable has no effect on the second variable, right? So it would be like watching the Food Network, watching the cooking channel helps you get karate skills, right? That's going to have no association. It doesn't matter how many hours of the Food Network that you watch, your mastery of karate is never going to go up. So those would have no association, and that's why you see this graph over here where the data just seems to be scattered all around. So that's going to be no association. Describe the type of association you'd expect to see between the following. A, the hours a person studies and the number of states they visited. Well, think about it. If you go home and you study and you study and you watch my videos and you look over the review, does that mean that you're going to go on vacation more, that you're going to just drive around and go to states? No, absolutely not. So over here we can write no association. Okay, and then B says the hours a person studies and their grade on an exam. So the more you study, the better your grade will probably be, right? So that's going to have a positive association. Okay, a positive association, because the hours would go up and the grade would also go up, right? And so they are moving together, and the one variable increases as the other one increases. And so that's going to be a positive association. So C says the hours a person studies and the hours they spend watching TV. Well, that's probably going to have a negative association, right? Because the more hours you spend studying, the less time you have to watch TV. So the more you study, the amount of time that you watch TV is going to go down. So we're going to say that this is a negative association. Very good. So now I'm going to be moving on to the next page, where we're going to try to use this information that we've just learned to work through some examples. But we're going to take a few more notes at the top of this page, and then we're going to do that, okay? So it says, if a straight line can be drawn to follow the overall trend of a scatter plot, it is linear. Okay, and we remember that linear means it seems to be moving in a line. So over here in this blank, we're going to write linear. Linear. Very good. If the points of data are close together, the association is strong. Okay, and then if the points of data are widely spread apart, the association is weak. And that kind of makes sense, because if the data is really, really, really close together, okay, I'm going to kind of put a few dots up here. If the data is really, really close together, it's very easy to see that line forming, right? And that it would be a positive trend because it would be moving up from left to right. But say the data was really kind of spread out, it might be moving up in a positive direction, but it's going to be kind of hard to fit a line through there so that we can see that it is linear. So this would be weak because the data is really spread apart, and this would be strong because the data is really close together. And if you thought about it like an archer, right? If they were going to be shooting at a target, the closer they can get to that bullseye, the stronger of an archer they're going to be. But if they're shooting at a target and the arrows are kind of all over the target, or they're missing some, that's going to be a pretty weak archer, right? So that's kind of another way to think about it. So we're going to look at these examples, and we're going to see what we can tell. So we're going to label each type of association. We're going to label whether it's a strong or a weak association, and whether or not it's linear, okay? So it's going to be positive, negative, no association. It'll either be weak or strong, and then it's either going to be linear or non-linear, okay? So for number one, we know just by looking at this graph, you should be able to see that all these points, okay, are moving up, and there's a whole lot of points that are really close to that line when I draw through it. And so we're going to say that since it's increasing from left to right, it's going to be positive. So I'm going to put POS for positive. All of these points are really, really close together, and there's a lot of them. So we're going to say that it is strong. And since it seemed to be moving in a virtually straight line, obviously all these points don't fall on a line, but it is moving in a straight, consistent form up this graph, we're going to go ahead and say that it is linear. Okay, so now look at number two. I'm going to go ahead and draw another line kind of down the middle of all these points. We're going to talk about that in a couple lessons or a couple videos. It's actually called a trend line, but we'll get to that. If you notice, there's not near as many points that are falling around this line. It is still a positive association, so we're going to put positive. And since there's not a whole lot of points gathered around this line, we're going to go ahead and say that it's weak. It's still a good positive line, but it's not very strong. Okay, and then it does make a pretty good line, so we're going to say that it is linear. Now, if we look at this graph and we kind of draw data through the middle of this graph, you'll see that this line starts going up. Okay, so it is positive because it does increase from left to right, so we're going to put positive. Remember, if I was like a little man and I was going to walk up this line, I would have to walk uphill, and since I'm going up, it's going to be positive. And since there's a lot of data that's showing us that it's going up, we're going to go ahead and say that it is strong. Okay, but is this going to be a straight line? Is this going to be a linear association? It's really not, because you can see that it curves. Okay, it kind of looks like a skateboard ramp. And so since it's curving and it's not going straight, we're going to say that it is non-linear. Okay. Now this next one, if you follow it, it seems to be moving down. And since that data is going down from left to right, we're going to say that it is negative. All of this data is really clustered pretty close together, so we're going to go ahead and say that it is strong. And then, since it does seem to make a really nice line going down from left to right, I'm going to say that it is linear. Okay, now we're looking at number 5. And I'm going to go draw me a line pretty much down the middle of this, and it seems to go over there at the end. Okay, and moving from left to right, if I was to walk down this line, again, I'm going to go down, so it's going to be negative from left to right. Okay. All this data is not really close together. There's not a whole lot of points here, so we're going to say that it is weak. And then if you see this little curve here at the end, it kind of looks like the end of a ramp or the bottom of a mountain where it's curving down to the ground. And since there's a curve there, it's going to be non-linear because it's not a straight line. Very good. And then this last one, if you look, I couldn't draw a line anywhere. So I'm going to say that there is no association. It's very weak because I can't tell anything about it. And then it's going to be non-linear because it does not create a straight line. Very good. Again, if you kind of think back to when we were talking about slope, positive slope, negative slope, and things like that, this should probably be coming pretty easy to you, but we just want to really make sure that we talk about everything and explain it. So now we're going to go through some situations in number 7, and we're going to determine if it's going to be a positive or a negative association. Okay, and if you kind of go back up here to your notes, remember we were talking about like the hours a person studies and things like that versus the number of states they visited. That's no association. That's exactly what we're doing down here on number 7. So it says, describe the type of association you'd expect to see between the following variables. So the first variable is a person's height. The second variable is a person's shoe size. Well, if we think about it, think about all of those tall people like Mr. Spatero that's next to my class. Well, the bigger the person is, the bigger their shoe size is going to be, right? So since that's going to have to be a big person to have a tall height, that shoe size would also have to increase. So for our association over here, we're going to put positive, right? Because as the person's height increases, their shoe size is going to increase. So as height increases, the shoe increases. Now, is that going to be true in every single situation? No, there's plenty of tall people out there that have small feet. There's plenty of short people out there that have big feet. But we're talking overall, the association is going to be positive because normally or usually, I won't say normally, but usually as a person gets taller, their shoe size is going to get larger. Kind of like when you're growing, as you get taller, growing up through the years, your shoe size is going to get larger. So the first variable for the second situation is the number of letters in a person's name versus the person's IQ. The number of letters in a person's name, is that going to have anything to do with how smart they are? Absolutely not. So we're going to say no association. No association. Okay? So, and the reason for that is, say I had a kid and I named that kid Nick, right? Just because I name a kid Nick, that's not going to determine his IQ or how smart he's going to be, right? I'm not even going to explain that one anymore. That pretty much makes sense. And then this third situation says the number of absences a student has and then a student's GPA. Now, you might not know what GPA is, but it means grade point average, so your average in the class, right? And if you think about it, the more often you miss your class, your GPA is probably going to suffer because you're going to miss the lessons, you're going to miss activities, you're going to miss opportunities to talk to me about work that you have or questions that you have about the work and things like that. Now, fortunately, I'm trying to make videos, so that might not be as true in my class, but overall, the more you're absent, the lower your GPA is going to be. So if one of them, the absences is increasing, but the GPA is decreasing, okay, you see how they are opposite of each other? That's going to make this a negative association. And if you were filling that out on a test or on a worksheet for me, and I saw that you put that arrow down and the arrow up because as the absences is going up and the GPA is falling, I'm going to count that as an excellent explanation, because I love the fact that you know that they're opposite of each other, and so that's going to give you a negative association. So the last bit of this lesson for 8 through 10, we're going to match each of the scatter plots with the possible description. So the first little description here says the temperature outside and the total gallons of gas sold at a gas station. B, the size of a home and the cost of monthly utilities for the home. And C, the altitude of a hiker and the total oxygen level in the air. Okay, so if we're looking over here at A, okay, it says the temperature outside and the total gallons of gas sold at a gas station. Well, does the temperature determine how much you drive? Not particularly, right? So, and this is talking about gasoline at a gas station. Now, if it was the temperature outside and the total, amount of gas sold at like a gas store for like butane tanks and stuff like that, that might be one thing. But it doesn't matter what the temperature is outside on the gas for your car. So we're going to say that this is going to have no association. Okay, the size of a home and the cost of monthly utilities. So utilities could be like the electricity. So if you have a big home, you're going to have to pay a lot of electricity, a lot of utilities in order to pay for like air conditioning and gas bills to keep it heated and things like that. So as the size of the home gets bigger, the cost of the utilities is also going to get bigger. And since those move together, it's going to be a positive association. And then C, it says the altitude of a hiker and the total oxygen level in the air. Okay, and I don't know how many of you actually go hiking and talk about Mount Everest, but whenever you go hiking and you go up high in the mountains, the air gets really, really thin and it gets really hard to breathe. So the higher you get, so I'm going to come over here to altitude. I'm going to put a little up arrow because the higher you get, your total oxygen level is going to go down and it's going to be harder for you to breathe. And since these are opposite of each other, that's going to be a negative association. A negative association. So we're going to come back through, and 8 seems to be going down from left to right. That's going to be a negative association. So we're going to put C because we said that C had a negative association. 9 from left to right, if I was to draw a line, seems to be going up, which would be a positive association. So I'm going to put B here because we said that B had a positive association. And then 10, of course, is going to be our last one, which was A, but we obviously see here that we couldn't draw a line because this data is all spread out. So it's going to have no association, which is what we said the temperature outside and the total amount of gas sold at a gas station is. Okay. So say you're absent or you're just wanting a little bit more information about this lesson, you could come back and watch this video. Then if you were working on your homework, you could just continue on and work on your homework. But maybe you were out of town and you didn't have an opportunity to get a copy of the work from me, or maybe you lost it and you just needed to make up that work. What you could do is I just completed this lesson in OneNote, okay? And so you'll have all of these notes and you'll have a link to the video up here at the top. I'll put a link to the YouTube video. You can click over to homework. And it will also say, just like this class note said, 10:30. You can go to homework and click on 10:30, and that's going to be the homework assignment. And you could complete it on notebook paper, write 1, show your work, give me the answer to A, the answer to B, and you could turn that in on notebook paper. You could even click up here and click on draw. You could select a pen type and use a tablet, during cat time or maybe another class or something if they were letting you work on homework, and you could work on it in OneNote, things like that, okay? If you have any questions, feel free to ask, shoot me an email, and I'd be happy to talk to you about it. So I hope you have a great day, and I will see you in the next video.